Good morning, everybody. Now, what we have is a voltage doubler circuit. I have a variac that I've got set to 0. You always want to start out at the lowest voltage value. That output of the variac goes to the input of this transformer, and the output of the transformer is rectified by this bridge rectifier back here. And the capacitor bank does the filtering and also the doubling. And I'll show you my drawings of this circuit so you can make one. Let's test it. Oh, look at that, I got this set to 0. There must be some output voltage because right now on the output of the voltage doubler I've got 80 volts. Let me get another meter and we will see what the input AC voltage is right here and right here. Grab the oscilloscope. We get untangled here. We'll set the oscilloscope right here. Turn that here so I can see it. Okay, on the input, the output of the variac to the input of the transformer, we have 7.5 volts RMS, and that's about 20 volts peak to peak here, negative 10 on the sine wave, and positive 10 on the sine wave. We're going to increase that voltage. That was 5 volts per division. Now on the output, we have 28.8 volts RMS. Increase that a little bit. We're at 20 volts per division, and that's 40 volts on the positive side and negative 40 volts on the negative side. That's about 80 volts peak to peak. So we have 80 volts peak to peak right here. On the output of the transformer. Let's increase the voltage a little bit. I want to hook that fluke oscilloscope to the output right here. So, the fluke oscilloscope is looking at the output of the transformer. Klein Tools digital multimeter is looking at the voltage on the output of the voltage doubler. Let's increase the voltage here gradually. We don't want to go too fast. We don't want to exceed the voltage across these two capacitors right here. Now in series, each of these capacitors is 450 volts DC. So in series, when you series these, I have 2 in series. That gives us a total of 900 volts DC that I can apply across those 2 capacitors in series. On the output of the voltage doubler right now, let it settle in. It takes a couple of cycles for it to totally charge the capacitors. I've got 464 volts DC right there. Let's get close to those 2 meters right there. I'm going to increase the output voltage right here with the variac. I'm going up very slow so that we don't exceed the voltage across those two capacitors. And I'm going to stop at 800 volts DC right here. Slow down. It's crept up to 821 volts. There's 822 volts DC on the output. Now we can see we have 294.5 volts RMS. That's our AC voltage right here, our RMS AC voltage. Let's see what we have peak to peak. It's 200 volts per division. There's 200, 400, 600, 800 volts peak to peak. Isn't that fascinating? All right, I'm going to turn everything off. And the DC voltage is discharging from these capacitors right here. AC voltage is turned off, the variac's turned off, and the DC voltage across those two capacitors is discharging. It'll take a while. I got some bleeder resistors up here, and they help to discharge those capacitors. If we didn't have those bleeder resistors up there, it would take forever to discharge those two capacitors. All right, folks, in the next couple of videos, I'll show you applications where you could use this voltage doubler. Thank you very much for stopping by and seeing what we're working on next. It's a little bit fascinating around here, doesn't it? Have a good day, folks, and we'll see you next time. Hello all. Now every now and then in your troubleshooting career, you're going to need a high voltage DC bus. And this circuit right here will provide it for you. Out here is plus bus, down here is bus ground. We have a line plug that plugs into 120 volts AC outlet on the wall. We have a variac right here, and we can increase and decrease the AC voltage at these 2 points right here. So if we have 120 volts AC in, we can increase this AC voltage right here, I believe up to 240 volts AC. Here is a transformer that the variac is connected to, and on the output side of the variac we have two diodes. The anode of this diode is connected to this side of the transformer. The cathode of this diode down here is connected to the same point. The other side of the secondary of the transformer is tied between these two capacitors right here. This circuit right here is called the voltage doubler. Let's see how it works. On the output of the transformer, when it swings positive, we're going positive. This diode right here is forward biased, and we charge up this capacitor right here. So current flows from here, charges up the capacitor, and back to the transformer. And we see that out here on this node right there. Now, when the secondary of this transformer swings negative, we were going positive, now we're going negative. This diode down here is forward biased. So current flows from here, charges up this capacitor, through the forward bias diode, now we're going negative, and this diode down here is forward biased. So we're charging up this capacitor right here through this forward bias diode back up here. So positive, we flow in this direction. Negative, we flow in this direction. So we're constantly flowing from here and flowing from here and flowing from here and flowing from here. Isn't that amazing? So what happens when we charge up this capacitor on the positive cycle, and we charge up this capacitor on the negative cycle, we have a voltage across here and a voltage across here, and we look at it out here. Here's our plus bus, and here is our bus ground. You have to be very careful. You don't want to swing this up so high that we overvolt these capacitors right here. In the video, working on the one Unitech drive, I only had to bring this voltage up here to, what was it, 250 volts DC before the switch mode power supply started up. But I brought this up to 800 volts DC on the output here. I brought it up to 600 and some odd volts DC out here. When I'm testing, say for instance, and I'll put a video up using this voltage doubler right here to test a Siemens brake module. The brake fires, the brake output triggers at about 610 volts DC, and I had to use this circuit right here to create that 610, 620 volts DC. Okay, we're going to put the complicated circuit up. This was the simple circuit, and I'm going to put the diagram up of the actual construction of that circuit. Can y'all see that okay? It's the same circuit. Here is the transformer. X1 and X2 terminals on the transformer I had connected to the variac, and the variac I could slowly increase the voltage, so I had my DC voltage out here, AC in here, DC out here for the circuit voltage that was required to power up that circuit that was connected here. The secondary H1, H3, H2, H4, the secondary of that transformer is shown right here. Now here is the two diodes. This diode up here, this is in a three-phase bridge rectifier, and I'm only using 2 diodes of that 3-phase bridge rectifier. This point right here is AC3. This point right here is plus of that 3-phase bridge. This point right here is minus of that 3-phase bridge. And here's the 2 capacitors that enable that voltage doubling out here. Plus bus and bus ground. I have 2 resistors in parallel with those capacitors. They're 51 kilo ohms, and they help to discharge. When I turn that voltage doubler off, I'd like those capacitors to discharge at a pretty good clip. Otherwise, we'd be here for a day or two before they discharge. So I got these power resistors out here to discharge that capacitor, and right here to discharge this capacitor. For the 2 diodes, I used a semicron power module for the 3-phase bridge, using only 2 diodes in that power device, and its part number is SKD60/16. There's the complicated diagram and there's the simplified diagram. Now you can use any parts that you would like. Whatever you got in your shop, you can use any part. Just make sure that these 2 capacitors out here will allow you to make that high DC voltage out there. You don't want to skimp on this voltage input. The microfarads, I think that any microfarad would probably work. 1000 microfarad, 3300 microfarad, but it's the voltage that you have to worry about. Don't undervolt yourself. When you increase this voltage out here and you overvolt these 2 capacitors right here, you could have some problems. Now when capacitors are series, the voltage doubles. So I got 450 volt here on this capacitor, 450 volts here on this capacitor. That gives me a range of 900 volts. 450 plus 450. Where you go? Be very careful with this circuit. Don't get yourself lit up with this circuit right here. Always be safe. Always be safe. And always assume that a circuit is live before you get across it. If you've ever been shocked and lived, you know what I'm talking about. Always assume that before you go and work on a circuit, it is live. I want you to turn this stuff off and make sure that these capacitors are discharged before you go and connect and disconnect from a circuit. Throw your meter at it and whatnot. Look at it with an oscilloscope. Safety first, folks. I'd like you to get up and enjoy your time on this side of the dirt tomorrow. Now, in the next couple of videos, I'm going to show you what I use this voltage doubler on. Here we're talking about theory, but in the next couple of videos, I'll show you a drive that I'm working on, brake module that I'm working on, using this circuit right here to create those high voltage DC to connect and test those circuits. Well, I'm getting a little bit long-winded here, of course, like always. Folks, enjoy your time with your family. We got a storm coming in from the west, and I got to go out back and fill up the bird feeders so they can get their chow before they got to hunker down. Thank you all for stopping by. We'll see you next time.